This video is going to cover section 3.1 for college algebra, complex numbers. Mathematicians don't like not being able to find answers, so when they came across square root of negative numbers and having no solution, they didn't like that. So they made up the imaginary number I. The definition of I is it's equal to the square root of negative 1. If you square both sides, then by definition, I squared is also negative 1. So essentially, if you have the square root of negative a, that negative sign is just an I on the outside of the square root. Standard form of complex numbers is a plus bi, where a is your real part, b is your imaginary part. If a equals 0, you have a pure imaginary number. So that'll look like 2i. If b is 0, you have a real number. That looks like 5. If neither is 0, that's when we have a complex number, and it looks like 2 plus 4i. The way they work, square root of 16 is 4. The negative sign makes the I. 75 doesn't have a perfect square, so we try to find something that does. We would say negative 25 times 3 is negative 75. Well, the square root of negative 25 is 5i. Leave the 3 inside. Now it's simplified. Your calculator will do square roots if we turn it on. So if you hit the mode button and then scroll all the way down and choose a plus bi, now your calculator will spit out i's. So mode is in this row right next to the second. You're going to arrow all the way down to the real number column and choose a plus bi and hit enter. Now your calculator will do i's. So we'll show you when you get there. Okay, negative 7 times negative 7. Using the rule up here, where negative a is I root a, this is like saying I times square root 7, and then I times square root 7, negative 7. Then I times I is I squared. Square root of 7 times square root of 7 is square root of 49. Negative 7 and negative 7 still makes positive 49. And then the square root of 49 is 7. So we'd get 7i squared. Well, looking up here, I squared equals negative 1. So it's like saying 7 times negative 1, which gives us negative 7. Let's try this one. So square root of negative 6 is I root 6. Square root of negative 10 is I root 10. Multiply those together, we get I squared root 60. 60 is the same as 4 times 15. The square root of 4 is 2. Leave the 15 inside, and then 2 times I is 2i. Dividing works the same way. This would end up being I root 20 over I root 2. The i's are going to cancel, and then 20 divided by 2 is 10. So we get root 10. Over here, the top would be I root 48. The bottom would be root 24. Now, we could reduce both, or I could say, hey, 48 is divisible by 24, and we get 2. So we have I root 2. That's as far as we can go on that one. So sometimes it's easier to just do it out, because if I were to do that on the calculator, square root, so I hit second x squared, which is in this row, and then I want to type negative 48. If I do that, I get a big long decimal with an I at the end. Sometimes it's easier to just keep our whole numbers in there, but that choice is yours. All right, now let's look at adding and subtracting. It's just combining like terms. You combine the real part with the real part. So 3 plus negative 2 is 1. And then we do the imaginary part. Negative 4i plus 6i is going to be positive 2i. And that would be our answer. We can also type that same thing right in the calculator. So in parentheses, those are going to be above the 8 and the 9. So parentheses, 3 minus 4. And then to get I, you hit the second button, which is the blue. And then you hit the decimal point. So second decimal point gives us I, close parentheses, plus, open parentheses, negative 2 plus 6I. And it spits out 1 plus 2I. So you can do it by hand. You can do it on the calculator. That's up to you. But pause the video and try those three. All right. Negative 9 plus 3 is negative 6. 7I plus negative 15I is negative 8I. Negative 4 minus 6 is negative 10. 3I minus negative 7I gives us 10I. 12 minus 8 is 4. Negative 5 minus negative 3 ends up being negative 2. So 4 minus 2I. Again, you can do those on the calculator. That's up to you. If you have two complex numbers being multiplied, we're going to FOIL. First times first, so it's the first term in each. Outside times outside. Inside times inside. And last times last is going to give us that I squared, which is the same as saying 8 times negative 1. So essentially, the I goes away and it changes the sign. Then we can combine like terms. 35 minus 8 is 27. I don't know why it keeps doing that. And then negative 10 I minus 28I is negative 38I. So we can do it that way. Or again, we can do it right on the calculator. 5 minus 4I, which is second decimal point. And then right next to that, 7 minus 2I gives us 27 minus 38I. Now, when you have a squared like this, just don't forget, it means you're squaring the whole thing. So if you do it by hand, you need to FOIL. If you do it on the calculator, you can just type the squared button. So you guys pause the video for a second and go ahead and do that. All right, so this one would end up being 16 plus 12I plus 12I plus 9I squared, which makes that negative. 16 plus negative 9 is 7, and 12I plus 12I is 24I. This one, 6 times 6 is 36. 6 times negative 5I is negative 30I. 5I plus 6I is positive 30I. 5I times negative 5I is negative 25I squared. Makes that positive. 36 plus 25 is 61. Negative 30I plus 30I cancels, so we just get 61. Your calculator, again, would do all of those. You can reduce I so that it always is either a 1, a negative 1, an I, or a negative I. Anything to the 0 power equals 1. Anything to the first power equals itself. I squared by definition is negative 1. And then I cubed would be I squared times I, so you would get negative I. And this pattern would continue forever. I to the 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, and so on and so forth. So they'll always reduce to one of these. The easiest way to do this by hand is to divide the exponent by 4 and then use your decimal to decide. So if you have no decimal, it's going to be 1. If your decimal is 0.25 or 1/4, it would equal I. If your decimal is 0.5 or 2/4, it would equal negative 1. And if it's 0.75 or 3/4, it would be negative I. So for example, 13 divided by 4 is 3.25. 0.25 tells us that this is the same as I to the first, which is I. The calculator will also do that for you. So if you type second decimal and then use this caret button to raise it to the 13th power, it'll spit out the I. So you try the other two. All right, 56 divided by 4 is 14 with no decimal, so it's the same as I to the 0 or 1. Negative 3 divided by 4 is negative 0.75. Because it's a negative, we would actually end up subtracting from 1, and we get 0.25. So this is the same as I to the first, which is I. Again, the calculator will do that. To the negative third, it tells you it's positive I. All right. Last part of this section is complex conjugates. To get the conjugate, you take the opposite sign for the imaginary part. So this first one, the imaginary part is 2i. So we would change it to 3 minus 2i. The second one is 4. There is no imaginary part, so the complex conjugate's the same exact thing. 3i is only imaginary, so the complex conjugate would be negative 3i. You use that to divide, because our whole goal is to get the i's off the bottom. So we can multiply by the conjugate of the denominator. So it would be 3 minus I over 3 minus I. Then we'd FOIL the top and the bottom. So 7 times 3 is 21. 7 times negative I is negative 7i. Negative I times 3 is negative 3i. Negative I times negative I is positive I squared, which by definition is negative 1. Then if I combine like terms, 21 minus 1 is 20, and negative 7i minus 3i is negative 10i. Now we do the bottom. 3 times 3 is 9. 3 times negative I is negative 3i. I times 3 is 3i. And I times negative I is negative I squared, which would become positive 1 because of that negative. And 9 plus 1 is 10. So we have that answer. All of the parts are divisible by 10. So 20 divided by 10 is 2, and 10 divided by 10 is 1. So this is the same as saying 2 minus I. Now again, I can do that. Well, let's do one more first. Down here, the bottom is I. So our conjugate is just negative I. Because we only have one term, we just multiply. 3 times negative I is negative 3i. I times negative I is negative I squared, which is saying negative times negative 1, which is really positive 1. So we just get negative 3i. Our calculator will also do these for us. So we can type this in as a division problem. Parentheses, 7 minus I divided by parentheses, 3 plus I. We get 2 minus I. 3 divided by I gives us negative 3i. So you try the other two. Whether you do it by hand or on your calculator, that's up to you. All right, if we do it out, we're doing 5 plus I here. So we FOIL. Our I squared makes this negative. Combine like terms. Then we FOIL the bottom, which makes this a positive 1. And then 13 is half of 26. So we could write 1 plus I over 2. We could say 1/2 plus 1/2 I. Those are both accurate. The calculator will end up saying 0.5. So if I do 3 plus 2i divided by 5 minus I, it's going to say 0.5. We can turn that into a fraction if we hit the math button and then we hit enter. This is saying, hey, turn my answer into a fraction. It'll give us the 1/2 plus 1/2 I version. Then if we did this other one, we would multiply by negative 2i. So 2 times negative 2i is negative 4i. 3i times negative 2i is negative 6i squared. And then 2i times negative 2i is negative 4i squared, which gives us negative 4i plus 6 over 4. Everything's divisible by 2. So negative 2i plus 3 over 2, or negative I plus 3 over 2. Both of those work. So that is section 3.1. Let me know if you have any questions.